Hello, welcome to lecture 22 of game theory course. We are entering the 8th week of the semester. We have been talking about, in the previous lecture, we have talked about the bargaining game where two friends, Sarah and Jane, are dividing their pizza. Okay, if you don't remember, go back and review what I have talked about. Okay, very well. Uh, the last page we have studied in the previous lecture was this. So by backward induction, at 1250, it's gonna be 40 against 0 because if Sarah gives Jane itsy bitsy small bit or even 0, Jane would say yes because you say no, it's 0, yes, 0. So what's the difference mathematically? So we don't have any grudges in Nash equilibrium. Just if you cannot get better, why not kind of mentality. So from here, right here, Jane should guarantee 40 for Sarah at 1240 because she's going to get 40 anyway. Jane can give more than 40, but that's not necessary. If that is the case, Jane's share will decrease. So the minimum 40 would be offered. As a result, 70 minus 40, 30 would be Jane's. As a result, Sarah would offer 70, 30. Jane said, oh, I looked everything and yes, this is the best thing, 30 for me. Okay, this is by backward induction, and we know what is going to happen in their mind. Everything was there, but then what appears in front of our eyes is Sarah offered somehow 70-30. Jane said yes. But like knowing what is happening is one thing, but writing down that as a game theorist, the writing down the subgame perfect Nash equilibrium is another matter. So how would you write it down? Like this. Sarah offers 12 at 12:30, 70-30. Jane's strategy is not just yes, because if Sarah offers 20, Jane would say no. So Jane would say yes only if Sarah offers her more than 30. I denote this like 30 or more. If less than 30, strictly less than 30, Jane would say no. Knowing this, Sarah knew that 30 should be offered as little as 30, so 70 and 30. But then, even though, the 70-30 offered, Jane says yes, so game ends here. As I said, we have to write down everything of the non-equilibrium path, which means what if Jane says no? What would be happening? If Jane says no, Jane would offer 40 and 30. Jane 30, Sarah 40 to Sarah at 1240. Sarah would say yes if Jane's offer to her is more than or equal to 40. Would say no if it's less than 40. Okay, makes sense? Yeah, that's Sarah's strategy. 1250, Sarah would offer 40 and 0. Jane said yes. If this number can be negative, we would say no if it's less than 0. But like we are normal person, we are not like the mathematician, like out of the world, like people. So we in healthy economist brain, we do not have the negative number in there. So yes, as long as it's positive number. Okay, this is it. Once again, 70-30 and yes. The first line is the equilibrium path. The second line below would be the non-equilibrium path, which would not be happening, but that gives a good ground. Basically, the reason why Sarah offered 70-30 and Jane said yes for that. Okay. Now, my favorite question, when I made this question like 13 years ago, 2007, like only less than 5% student got it right. The question is, we know that in this game of the pizza division, this is a subgame perfect equilibrium. This is the only subgame perfect equilibrium actually. However, this game has Nash equilibria that is not a subgame perfect equilibrium. Okay. If you are, I want you to stop this lecture video and think it yourself. Maybe 10, good 20 minutes. What would be the Nash equilibrium that is not this subgame perfect equilibrium? Okay? Think it over and coming back. See you in 10 minutes. Okay, 10 minutes passed. I knew that you thought about it 10 minutes. Now you're coming back. I'm quite sure if you don't have idea about the Nash equilibrium that is not subgame perfect equilibrium after 10 minutes, you're just the majority of university smart student, like 95%. If you thought about that and found out, wow, you are the top 5%. Let's see. There are actually many Nash equilibria that is not subgame perfect equilibrium, but this is one of them. Okay? If this does not surprise you, I would be impressed. The Nash equilibrium is like this. Sarah offers 100 to 0. So Jane would get 0. Sarah, 100. Jane's strategy on that at 12:30 is no to anything. It's not because this is 0, but if Sarah offers 0 to 100, Jane would say no. So this no, no, no means if you say, oh, Sarah says, I'll get 0, I'll give all the pizza to you, Jane, Jane still say no. Okay? That is the strategy for Jane. Because no, then Jane offer. This time Jane says, I got all the pizza, 70 of it, and give you Sarah 0. And Sarah says, no, not only to this 0, whatever offer you make, no all the time. All the time. This no means all the time. This is different. No if. When yes means yes for every offer. No, yes here is yes if this condition is satisfied. I wrote down no, no, no. Whatever offer is, I keep saying no. Sarah, then 12:50 offers 40, 0, which means Jane gets 0, Sarah gets everything. No. Okay? So what is happening is the negotiation fails and nobody gets the pizza and they go to the class with empty stomach. And our great John Nash, the Nobel Prize winner, says this can be happening because this is a Nash equilibrium. Okay? And this is very bizarre. We wouldn't expect it to be happening in the real world. And that is why the game theorists couldn't stop at Nash equilibrium. We are still in the job of finding out better equilibrium. Okay. Why is this Nash equilibrium? Let me remind you the definition of Nash equilibrium. Nash equilibrium is once you begin to play it and thinking about changing your strategy, you can never get better than that. Here, the payoff for Sarah and Jane, if this is Nash equilibrium, would be 0 because no, 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 nobody eats 0 and 0. And let's say if they can get any payoff bigger than 0, you say, oh, that's easy. I mean, this pizza value is 100 at first, 70, 40. They can get like 1. Really, let's see. Sarah can change these 3 things. 12:30, 100 to 0, 1240, 1250, 40 to 0, 1240, no. Let's thinking about changing the offer 1230 and 1250. If Sarah offers, okay, sorry, it's not 0, I'll offer you like 10, 20. Here, okay, 30 something. What would be happening? Can Sarah get any better than 0? Jane's strategy is flat out no for every offer. So even though Sarah said 50-50, Jane would say no. Even Sarah said 10 and 30 for you, Jane would say no. Because that's Jane's strategy. So by changing offer here, Sarah cannot get yes from Jane because Jane is determined to say no to every offer given to her. Does that make sense? No. By backward induction, why would you say no? Because you would get 0 now, and 50-50, you can get 50. However, we are talking about Nash equilibrium. Nash equilibrium, you believe in the empty threat, whatever your opponent would say. So if Jane says no to anything, Sarah believe it. Even though I said, oh, I'm going to give you 90, Sarah believed Jane would say no. How stupid of Sarah? Well, that's Nash equilibrium. In Nash equilibrium, you think your opponent, whatever the opponent say, you believe in it. Like your son, if you don't buy me a bike, I'm gonna run away from you, never see you again. Mom believes in it. That is Nash equilibrium. So this fits Nash equilibrium, however awkward it may look. What about the second? No. Sarah may change from no to yes. Then, wow, lucky for her. Now, it does not go all the way down here. The game stops at 1240. Because Sarah says yes to Jane's offer, which is 0 for Sarah. Wow, what's that? Sarah, if follow the original Nash equilibrium, she gets 0. Now say yes, she gets 0. The payoff didn't get any better. So the Nash equilibrium says, if your payoff gets strictly better, that's not Nash equilibrium, but if remains the same or worse, then that is Nash equilibrium. So Sarah, by changing any of these three strategies she has at the three critical times, she cannot get out of 0 as long as Jane maintains her stance in the strategy. Now, what about Jane? Sarah offers 0 to her. Jane think about yes. Yeah, then game ends here, but now she gets 0. Changing to yes, she gets 0 too. Same here. She can change to yes, but right now she gets 0. Say yes, she gets 0. So it doesn't get any better. Jane may change this 0 to 70 to like 30 to 40, something like that. But Sarah is going to say no to any offer. Even Jane said like, oh, I'm going to give you all 70 and I'm getting 0. Sarah says no, because that is her strategy, whether that is believable or not. Totally unrealistic strategy, but still, that's Nash equilibrium. You cannot say in Nash equilibrium that strategy is totally unrealistic. It's just as long as the other player plays the Nash equilibrium strategy, can I get better by changing my strategy? In this situation, they can't. That's why how ridiculous this equilibrium strategy may look like and how ridiculous they are to get 0 and 0 while they can get 100 or 70. This is Nash equilibrium. Okay? I think this is the last phase of Nash equilibrium. Like if you think like 10 minutes ago, oh, I understand Nash equilibrium. Now you got confused again. Most of people do. But if you get over this, then I would say you almost understand Nash equilibrium. Because Nash equilibrium is not common sense. Nash equilibrium is mathematically defined concept, and you should just follow that Nash's mathematical definition. Once you confuse them with your common sense, you are in a big trouble. Okay? So, we are saying, we are not saying the Nash equilibrium is something realistic and wonderful. If that is the case, the economists would have stopped studying anymore when Nash found out Nash equilibrium. Nash equilibrium is a big advantage that every game we have Nash equilibrium. In addition to that, any equilibrium that makes sense until now belongs to Nash equilibrium almost all the time. However, that does not mean all Nash equilibrium makes sense. There are horribly ridiculous Nash equilibrium like this. This I don't think would ever happen between pizza dividing game between Sarah and Jane, but we cannot deny this is Nash equilibrium. So subgame perfect equilibrium is invented to get rid of, delete this kind of ridiculous Nash equilibrium. What is another Nash equilibrium that is not subgame perfect? Here, Sarah offers 70-30, and Jane say yes if it's 30. Oh yeah, so this game ends at 12:30, like our subgame perfect equilibrium. So the first line is the same. Actually, the second line is the same. Okay? Yes if 30. So the game ends here. So the equilibrium path is same as subgame perfect equilibrium. What would be different from subgame perfect equilibrium is the non-equilibrium path. This ridiculous Nash equilibrium is kind of unique that even the equilibrium path is different from subgame perfect equilibrium. But the easier trick is if somebody asks you find out a Nash equilibrium that is not a subgame perfect equilibrium, the easy trick is you do not touch the equilibrium path and you do some trick on the non-equilibrium path. Once 70-30, Jane offers 10-60 and Sarah says no for any offer less than 50. Okay, so she would say no for this. What I have omitted is yes if it's 50 or bigger. Okay, I missed that. But anyway, so the game ends at 12:30. Jane offers this very little for Sarah. Sarah would say no. And next, Sarah offers 20-20. Jane would say yes. Okay. So what is happening? What in this non-equilibrium path? What would be happening is, it wouldn't be reached, but Jane offers this no and 20-20 yes. So Sarah would get 20, Jane would get 20. Okay, but then 12:30, they think about 70-30. Sarah said, oh, if I offer something else less than 30 and go to the next phase, oh, I'll get 20. So 70 is the best I can do. Jane says, I'm offered 30, oh, too little, but if I go one more step, I'll get only 20. Jane can even think about, okay, I can offer Sarah not 10-60, but because Sarah wants 50-20, because the sum should be. Then Sarah would say yes in 12:30, but then Jane would get only 20 after giving 50 to Sarah, which is less than 30. So Jane says, oh, whatever I do later, I cannot get any better than 30. And the next step, Sarah would offer 20. So if Jane says no, the only two ways she can get any offer is she says no and go all the way 12.50 and get 20 because Sarah would offer 20, or change the 10.60 to 50.20 and Sarah would say yes, Jane would get 20 from there. So Jane can the best Jane can get after 1230 is 20, as long as Sarah maintains this idea. And Jane would say, oh, I prefer 30 more than the 20. From Sarah's point of view, if she goes here, she would be offered only 10. If she says yes, she gets 10 instead of 70. If Jane offers, the next stage, 2020, she will say yes, but 3010, no. So Sarah says, the best I can get after this is either 10 or 20, which is much less than 70. So it's in their mind. Of course, Jane would say not only if the offer is more than 20. 10, Jane would be happy to say yes. 1, even happy to say yes. So all these offers are not realistic, but still, when you mess up with this non-equilibrium path kind of nicely so that you do not make any change in the equilibrium path, I think you are very likely to have a Nash equilibrium that is not a subgame perfect equilibrium. Okay. Next is the trick to how you can get a better deal in negotiation. That I would rather do in the next class. So why don't you have a good look? What about let's change like this. One more example. If in subgame perfect equilibrium, instead of yes if bigger than 30, no if less than 30, you change it such that Jane says yes only when the offer is 30. If Sarah offers like 40, 50, she would say no. She says yes only when it's 30 and no when it's not 30. Like bigger than 30, less than 30, she would say no. That doesn't make sense because if you are offered 40, 50, that is better than 30. Why would she say no? However, if she has that strategy, and also here, Sarah says yes, only the offer is 40. If the offer is like 50, 60, no. 30, 20, no. If we change this Jane's strategy and Sarah's strategy about yes and no like that, that would be another Nash equilibrium. That is not subgame perfect equilibrium. Of course, what would be happening is Sarah offers 70, 30. If Sarah offers like 69, 31, Jane would say no. She wouldn't do that. If like 71, 29, she would say no. Jane would say no. She wouldn't do that. So exactly 70, 30 would be offered by Sarah. Otherwise, her pay of 70 would be dropped. Either 40 to 40. So she will maintain 70, 30. And Jane would say yes because 30. But then why would she say no for like 40? Sarah would never offer Jane 60, 40. So it doesn't matter, however ridiculous it may be, Jane says, Sarah, if you offer me 40, I'll say no. Sarah said, I'm going to offer you 30 anyway. So whatever Jane says about that does not affect Jane's payoff. So this ridiculous strategy that I say yes only when it is exactly 30. If it's bigger, I will say no. So there are really a lot of Nash equilibria in this game, even though there is only one subgame perfect equilibrium. So sometimes I make an exam question like find out 3 Nash equilibrium that is not subgame perfect equilibrium. You should do that. So why don't you, after this class, have more fun finding out a couple of more Nash equilibrium in this game that is not subgame perfect equilibrium. Okay? After you're doing that, please come back to the next lecture, lecture 23 next time. This has been the lecture 22. Thank you.